Okay, welcome back. Let's see what you did on number 3. So your domain should be -3, 0, 2, 9, 23. And your range, oh, that curly bracket kind of got a little funky. Yeah. -99, 0, 7, and 14. So hopefully you got that correct. Now let's move on to functions. Remember, it was relations and functions. So let's talk about functions. So a function is a relation in which each element of the domain corresponds with exactly one element of the range. So the question is the relation a function? I'm going to go ahead and draw in number 4. Go ahead and take a second, pause it, and draw that in. And we're also going to do a number 5 as well. Please pause so you can draw that in. Let's talk about it. So a function is a relation, so it's a set of ordered pairs, in which each element of the domain, or the x values, corresponds exactly with one element of the range. So for number 4, is this a function? Is there every element of the input, or the domain, correspond with exactly one element of the range, or the output? The answer is yes. This is a function. How about number 5? Does every element of the domain, or the input, correspond with exactly one element of the range, or the output? And the answer is no. It doesn't, because 2 has 2 different output values. It has 2 arrows. So this is not a function. And the reason being is that 2 corresponds with -3 and -1. You see it right here. Corresponds with 2 arrows. Okay. So that's one way of telling if a relation is a function. The next way you can test if a relation is a function is on the graph, which is called the vertical line test. It is used to determine whether a relation is a function based on a graph. Well, how does it determine it? Well, it determines it by if a vertical line passes through more than one point on a graph, then the relation is not a function. So let's test that theory out. So I'm just going to draw some mini grids, and I'm going to draw some graphs on there. And they don't have to be super specific, but they should look like what I've drawn. And I'm going to use two different colors. So I'm going to use one color to represent the graph. And I'm going to use another color to represent the vertical line test. So here is my example of my graph. Okay, we have a nice linear graph. And in this graph, we have a parabola, which is something we'll learn about this year. Okay, so now the question is, are these functions? Well, the test says that I simply draw a vertical line through the graph, and if it goes through more than one point, then the relation is not a function. So if I draw a vertical line through my equation or through my graph, how many times does it pass? Well, it only passes one time. So therefore, this is a function. Let's try the same thing on number 7. If I draw a vertical line on this one, how many times does it pass? It passes it twice. So therefore, this one is not a function. The last thing we're going to talk about today is function rules. So function rules is an equation which represents an output value in terms of an input value. So for example, if I had an equation said y equals 3x, this is a function rule because you have the output, the y values, in terms of the input. These are things you see all the time. What you don't see all the time, which is new, is function notation. Now you've seen this before in Algebra 1, but it's good to remember. Function notation is when you change y to f of x. So say that again. This is called f of x, which is shorthand for a function of x. But really it could be any variable. So you could have a function of y, you could have a function of k, a function of a, okay? It's whatever variable is being used in the function rule. So how would I write this function rule in function notation? Again, all I do is change the y to f of x. So instead of y equals 3x, I now have f of x equals 3x, which again means that I have a function of x that equals 3x. Okay? And it's one of those things that it'll get easier as you go. But now we're going to use that knowledge to evaluate function notation. We're going to evaluate f of x, and we're going to write the answers as an ordered pair. So number 8, f of x equals 8x minus 7, for x equals 3. So I'm going to substitute 3 wherever I see x. F of 3 equals 8 times 3 minus 7. Now, this left side will not change, okay? Again, all you're saying is that you're taking a function for that value. So you're just expressing to me that you're taking a function and evaluating it for 3 instead of x. So I'm going to keep function of 3 equals 8 times 3 is 24 minus 7 means f of 3 equals 17. Okay. But how do I write this as an ordered pair? Well, what did you put into the equation? Or what did you put into the function rule? You put 3 in. So 3 has to be my input. What did you get out of it? You got out of it a result of 17. So therefore my answer is 317. We have one last question for the day, and I want you to pause this one and try it for yourself. So go ahead and pause, and I'll pause for dramatic effect and try this one out. I hope you paused or enjoyed my little Jeopardy jingle. So f of 12 equals 5 times 12 minus 22. F of 12 equals 60 minus 22. 60 minus 22 is 38. So my final answer as an ordered pair would be 12, 38. And that is the end of your lesson. You may go ahead and access your homework now. Have a great day.